Okay, now at this point or portion of our discussion, we're going to talk about, we finished already in the last discussion with simple interests. Now this time, we're going to have a compound interest or compounded interests. Now, compounded interest, let me just read to you our definition. Okay, compounded interest is the procedure in which interest is periodically calculated. So the interest here is periodically calculated, and it's not just calculated once. Periodically calculated, so there is a period here. Interest rate is, there are two interest rate considered. There is the per annum, and then there is a periodic interest also, which the per annum is distributed according to the number of conversion rather. Now, what happened for compound? It's like this. Example, this is the principal amount. In the first period of interest, example, first period of interest, during the first period, you have this interest added to the principal amount. Now, in the second conversion, the second period, your principal amount now is plus the interest of the first conversion. So, this is now actually the story when they say interest also gain interests. Because during the second computation, the second conversion, during the second periodic computation, the principal amount now is already the principal plus the interest generated during the first conversion. So, the principal amount now plus the interest, then plus the second interest until you have to finish the entire duration. That's why compounded interest is quite heavy to consider if you are going to borrow a loan, because an interest will also gain interests. That's how compounded interest work. Now let us look at the situation here. First, let me just introduce to you to our compounding frequency and periods. Now, this is the common, but of course there are still other compounding frequencies, but I just prepared here the common one. Okay, we have the compounding period. We have annual, semi-annual, quarterly, bi-monthly, and then month. And then the number of conversion per year, when you say annually, that is equivalent to 1. Semi-annual, that's 2, twice a year. Quarterly, that is 4. Bi-monthly, that is 6. And then monthly, of course, is 12. Now, for the compound period, or compounding period rather, or conversion period, this is equivalent to 1 year. And then 6 months, and then this is 3 years, 3 months, and then this is equivalent to 2 months, and then this is 1 month. Meaning to say, in the compounding period or the conversion period, interest is calculated per year if it is annually. So the compounding period computed using annual computation is just very similar to simple interest only during the first year. But on the second year, there is already a difference, because the interest generated during the first year will also now be included in the principal amount in computing during the second year. And then when you say semi-annual, every 6 months is the computation of interest. This is our periodic conversion. And then for quarterly, in every 3 months, interest is calculated based on the annual interest rate given. And then by monthly, every 2 months. And then monthly, of course, every month. There are others that the compounding or the conversion period is every 15 days. Okay, that's also possible. Now, here are actually the variables that we will encounter when we talk about compound interest. We have maturity value, that's capital F. Principal amount, the money borrowed or invested, that is P. I here still an interest, but of course, we're talking about compounded interest. Interest that is generated several times or according to, computed periodically. And then J here is the nominal interest rate. Okay? J is the nominal interest. That's the interest rate given in a certain duration, or that's for the entire term. But of course, there's a compounding period. For example, the nominal rate is 12% per annum. and then compounded quarterly. So the 12% will somehow be cascaded into 4 computations. Okay? And then M here is the number of conversion. The number of conversion is this one is either 1, 2, 4, 6, 12, depending on your compounding frequencies. And then T refers to the period, how long your loan or investment would run. 2 years, 5 years, that depends upon. And then I here is the periodic interest rate. The nominal interest rate is the interest imposed to the money invested or borrowed. While the periodic interest, it is the cascading or the cascaded nominal interest now according to the period, referring to the number of conversion. So for example, if it's 2, so interest using the nominal interest rate will be cascaded into 2 computations during the first 6 months, and then after the second 6 months in a year. And then N here is, wait, I forgot to write what's N. N is the number of conversion. Number of conversion. So the number of conversion refers to, wait, what's the difference between M and N? The number of conversion of the loan, number of conversion of the loan. Okay? So, but later on, there is also a computation for M and computation for N. Wait, where is the N here? Anyway, we'll just get to know them later on. So, N is, where are you? This is our first example. By the way, N here, the number of conversion, how many times you will compute, I forgot the term. Remember, based on the periodic table or the periodic conversion, that's I, you're going to count the total times. You're going to compute the interest of the borrowed money or invested money according to the number of conversion and then the total period. No wonder that N is simply TM. That's the duration times the number of conversion, or how many times a borrowed money and or invested money will be converted, or could be how many times the conversion is in a year, for example. Anyway, to walk you through, these are our basic formulas or the formulas that we may use, but there's still other. I just try to use prepared here some of the common. We have here the future value equals principal amounts is the quantity of 1 plus I, that is periodic interest rate to the power of N, which is the product of time and then the number of conversion. And then you have here the computation for P 2 ways, but actually these are just the same. That's why it's OR. You can have it this one or this one, but I prefer to use this one just to avoid the negative exponent. And then I equals F minus P. And then J of I equals J over M. That is the nominal interest rate divided by the number of conversion. That's for I. And then for N equals TM. That's the number of conversion times the duration. Now, I think I just walk you through with the basic things that we have to understand first before having an actual example. Let's have our first actual example under compounded interests. Okay, our first example is Okay, we have here our problem. What will be the maturity value? Take note, maturity value, so we're solving for F. The maturity value or the amount due. Of an amount 12,000, this is 12,000 as your capital or your principal amount invested for 4 years. This is the duration. And then you have, this is the J, the nominal interest rate. So if we will try to get to know our given, let's start with, of course, F is unknown. That's what we're looking for. Our principal amount is 12,000. Okay? And then, what else do we need? We have our M. M refers to the number of conversion. You notice it says here compounded quarterly. Under quarterly compounding, the number of conversion, which is M, is equivalent to 4. Because that's for every 3 months. And then, what else do we need? We have also our T. T is 4 years. That's the duration of our term, or the term. That's 4 years. And then next is we have our J. The nominal interest rate is 15%, so that is 0.15. And what else do we need? Our I. Simply I, as computed, is J over M. So that is 0.15 divided by 4, which the answer is, what is 0.15 divided by 4? Approximately 0.0375. And then we also need our N. Again, N equals TM, which is time times the number of conversion. How many times interest will be calculated for over the entire term? So that is simply 4 times 4, which would give us 16. Meaning to say, in the entire duration of this investment, 16 times an interest will be calculated. Okay, that's the meaning of N. Now, let's have our computation. First, we will use our formula. Since we're looking for the future value, again, our future value, the formula given to us was, what was that? We have future value equals principal amount times the quantity 1 plus I raised to N. Okay, that's correct. So we will just use the value here. Anyway, we have identified already our given, so we just simply substitute them in our equation. Our principal is 12,000. We have here 1 as our constant value, constant term, plus our I is 0.0375 raised to our N, which is 16. Now, technically, you have to work it with your calculator because you notice that's already raised to the power of 16. So, calculating it, okay, you have to use your calculator by this time. 12,000 times 1 plus 0.0375 raised to 16. That's equivalent to 21,626.73. It's 21,626.73. Now, this is our maturity value. Hence, the maturity value is 21,626.73 pesos. Okay? So, I think the very thing that we have to master here is we know how to identify the variables as our given, because once you have them and you clearly stated them here, surely there's no problem with our substitution. And then, your calculator will do the rest of the work. Let's have one more example under this one. And you still have times to check some other sources for this one because I cannot discuss all the possible example under compounded interest. Okay, do not limit yourself to sources like this one. But of course, you can welcome other resources to do the computation, or at least do compounded interest. Our next example is just one. Okay, now in this problem, Salome paid 8,600 on a loan made 2 years ago before at 16% compounded by monthly. Find the interest generated. So in this case, we're asked to find the interest generated. What happened was, there was already, this is the interest amount paid of a loan that was paid several 2 years ago. Let's start with identifying we have our future value. We don't have it. We have our principal amount. In this case, future value I think is not necessary. Let's just remove it. Let's start with the principal. Of course, principal amount here is not known. Okay, we don't know the principal amount. And then we have our first principal amount. Of course, interest is not yet, interest is known, which is 8,600. Our M is bi-monthly, so meaning to say that is 6 every 2 months. Okay, that's bi meaning 2. Every 2 months, that's our compounding, our number of conversion per year. And then our T is 2 years. And then our, what else do we need? We have F. I'm really sorry. This is not the interest. This is the future value. Future value in the sense that this was the amount Salome paid all in all for after 2 years of the money borrowed. We don't actually know how much was the interest generated, but that's our concern. So out of the 8,600, how much was the interest here and how much is the principal amount? Okay? So we have here M, then T, we have next is our J, the nominal interest, which is 16%. 16% or that is 0.16. And then our N, our total number of conversion is simply 6 times 2. 2 years, and then for 6 number of conversion, that is going to be 12. And then what else? That's T is already there. Our I, for the nominal interest or the periodic interest rate, that's J over M, which you have 0.16 divided by 6. Our answer is 0. I'll just change this one to 6%. It was just 6%. I miscopied it. So that is 0.06, which is 0.1. 0.01. Okay? So, we have now our given. First thing that we need to do to find the interest is we have to look for, simply we look for the principal amount. We have to find the principal amount, so that's subtracting the principal or the maturity value with the principal amount, and we will get the interest. So first, actually, what we're going to do is we will look for the the principal amount. P, there are two equations for the principal amount. I'm just going to use the one without the negative exponent. So I'll have, what was that? forgot the formula. It is future value divided by the quantity 1 plus I raised to n. Okay, did I copy correctly? Yeah. It's I. That's correct. So, let's substitute now. Our future value is 8,600 divided by 1 plus our I. Where was our I? 0.01 raised to our exponent, which is n. That's 12. Okay, there you go. Let's compute now. That is 8,600 divided by 1 plus 0.01 raised to the power of 12. That is 7,632.06. Let's just approximate our value, which is 7,000 pesos, 7,600. My calculator is not really clear. 0.06. So this is the principal amount. That's the money Salome borrowed. But the question here is how much is the interest generated? Of course, we have to solve I equals future value minus principal amount. Our future value or the maturity value is 8,600 minus the principal amount of 7,632.06. Okay, let's subtract. Minus 8,600. So approximately we have 9,000. Wait, 900 rather. 967.94 pesos. So to answer this problem, to help Salome, therefore, the interest generated from the money borrowed is 967.94 pesos. That completes our problem related to Salome's question. Okay, so I suppose that's all for today. I provided several or at least two examples under compound interest. But like I said, do not limit your answer. If you wanted to explore more, you can check other example online of other problems related to compounded interest. I'm sure I don't have all the luxuries of time to discuss to you several or different situations or problems related to compound interest. So please do not limit your knowledge, do not limit your sources to what I have provided you. Of course, you're always free to check out. So like I said, if you have some question, you can leave your questions in the comment section of this video, or sometimes, or even you can just PM directly, send to me your questions via messenger so I can answer them as much as possible or as soon as possible. I can provide you feedback with whatever questions you've got for me. Okay, like again, why I'm doing this one, because this is to solve the problem related to a better quality or resolution of video streaming once checking our lesson. So with that, thank you so much for watching, and then I hope you enjoyed our discussion about simple interest and compound interest. So that's all for now. See you around.